Okay, so I think as you mentioned, we've got a great set of panelists, and I'll just need to do the simple job of padding off certain questions to them, and we'll try and get the audience in also pretty soon. So the first question that I had is, we've been listening about AI all the time. We open our news, we see AI, everything, all the time we are only seeing AI. So maybe I'll ask this to Pedro, right? So Pedro, do you want to just give a quick introduction of yourself and then answer this question? If AI were to solve everything, then why isn't everything solved yet?
So my background is technical. I've been doing AI and machine learning for about 17 years. 60% academia, 40% in industry, about 12 different industries, and saw a lot of the failures and successes in AI. I think very quickly, why is AI not solving things? Problem number one is a talent shortage, right? I interviewed over 300 data scientists, and I think a great data scientist is a person that's a mathematician, statistician, machine learning scientist, software engineer, who understands the business. And that is a unicorn, and you can't mass produce unicorns, right? But the interesting point is, once you find a unicorn, you're still almost guaranteed to fail. And this is where it gets interesting. It's where that unicorn wants to spend their time, right? If you look at a data science or an AI engineering project, you start with strategic problem formulation. What can we do to improve our business? Then you take that and you say, how about change this business problem into a data set? I'm not talking about clean data wrangling, just turn it into a data set. Then you start where the data scientist engages, which is cleaning the data, wrangling, missing values, feature engineering, algorithm selection, tuning, hyperparameter optimization, and productionizing the model. That's where they start, that's where they end. After that, though, there's having the business user that trusts and understands the model and actually uses it so it impacts the business. The middle part is where your own unicorn is going to spend 99% of their time, and it's the least valuable part. The beginning, strategic problem formulation, and the end, getting the business user to actually impact your business with that model, are the most important parts, and that's where the data scientist is not spending their time. So that creates a problem for getting companies to get success. I mean, I've hired the number one data scientist in the world, won more capital competitions than the next 5 people combined. And I asked him, were most of your projects successful? Clearly, you can build better models than anybody else. And he said, no, the vast majority of them were failures. Now, they were a data science success. He built an accurate model, and they were a business failure. And it's because of that. So you have all these data scientists spending all their time to build a better model, when just look at the best person. Even his projects are failures. Why are you spending your time doing the thing that, even if you get that good, you're still going to fail? That's why, I started Ople. Can we replace that middle component so the data scientists can spend their time doing something else?
So AI to help AI folks, etc. The question I had is, Biren, you work for a large enterprise firm, and I'm sure AI is something that you're trying to use. Could you give us, and I think the theme of the conference is in terms of looking at challenges that large companies such as yourself face, and how easy or difficult is it for you to absorb and assimilate the technology that may be there or not be there. So could you give us a flavor of the challenges and how you're trying to solve them?
Yeah, so the flavor of the challenges, well, it starts with the unicorn and finding the right unicorn to be able to solve the problems that you're trying to solve. But then add to it just the scale. So when you're talking about large companies, where you're getting billions of data points coming in at you, terabytes of data coming in at you per day, being able to not just convert that into something useful. So all of the data engineering aspects that Pedro just talked about. But then, and I absolutely agree with what he just said, is after you've done that and you've learned the model, you've applied the model, the trick is really, is that model solving the problem for you. And that's where you typically see things fail. Despite all of the models being built, all of the data being cleansed, and by the way, speaking of enterprise companies, that's the other issue we have, is data coming at us from various sources, from various verticals and so on, that look completely different. And so a vast majority of our time is spent on just doing the boring part of the job, which is data cleansing and getting the data ready for AI. And then once you've done the AI, then ensuring that what you've come out with is actually something that business needs and that has business value. So that's kind of where the problem lies.
Cool. So Jason, you're doing a lot of things around helping solve exactly these kind of challenges that large enterprises face in implementing AI for their platform. So could you give us a flavor of how you're trying to do that?
Yeah, so my name is Jason Pohl. I'm a director of field engineering at Databricks. So our company was co-founded by the original co-creators of Apache Spark, which is kind of the most popular de facto open source project for big data. It allows you to process data regardless of what your scale is, and it doesn't matter if you're processing it to just sum up numbers or to build a machine learning model. You can do it with Apache Spark. And Databricks is a hosted platform that allows you to have a unified analytics platform to combine the work of both data engineers and data scientists, because even though the value you're going to get is out of building that machine learning model, you have to do a whole bunch of other stuff before you can get to that point. So you have to prep and cleanse and get to your data. And, for example, one of our customers we work with is Apple Computer. They had a problem where they were monitoring all the network devices on their network, all the entry points, and they would do some network intrusion analysis in their existing solution, only let them look back in time about 2 weeks because they get about several petabytes of data every week. So we worked with them, and now they're able to go back several years and see from that initial signal, and they work their way backwards, like when did that intrusion originally occur? And that's the type of problems you have to solve at scale. And it's not just with the machine learning, but you have to do the data engineering first.
Interesting. So Ruchi, I want to bring you in. Right? So we talk a lot about the technology. I'm sure all of these investments that are being made is not simple. It's not easy. And I think before we got in, we heard about the millions being spent. And I think what you mentioned is the help that you are doing in terms of helping companies monetize this, and in fact productize some of these things. So I just wanted to get your thoughts on that.
Absolutely. So there are certain things which are really monetizable. So there are certain use cases like Amazon's of the world where they are using this data. For example, one of the use cases they use this is to optimize routes in the developing countries where there's not much of law and order. So while the delivery trucks are on their way to deliver some of the goods, they get stolen. So just taking a lot of data sets, processing that, and saying that this is the time of the hour you need to be on those routes, and so by optimizing that, they save millions of dollars. So their investment versus the goals makes sense. But then in certain companies, which are more new companies, and some of the examples you would know, for example, you see Gmail, right? There are smart replies there. That's an example of AI, but how many of you are willing to pay for that smart replies? That's one clear indication. Or, for example, another web companies, when they show you personalized recommendations, that's again, they are using underlying AI, but how many of us are willing to pay extra dollars for that? So I built a product in my previous company, which was embedded AI cloud persistent chat platform. And just by applying AI to it, right? Like, so this means when I say applying AI, that every message that got into the platform needed to be annotated and processed and everything. We just added 30% of the infrastructure cost. I'm not even talking about the cost of all the data scientists and everything. So again, you have a huge increase in just infrastructure cost, then there's a people cost, and then there's a training of the data cost, right? So especially in enterprise set, data doesn't come freely. So it needs to be very domain specific. So acquiring that data and then just putting those models to be trained on that data is a cost to them. So now when you go and try to sell that product, then how much premium you can charge of that? So that becomes a really big question. And people question that, right? Like, and then you always play with this accuracy and all those, like, how accurate your product needs to be before someone would start paying you for that. So in certain use cases, very simple, like you can show direct return on investment, but a lot of consumer-facing products, it's very hard to show that direct correlation.
Interesting. So I think we spoke a lot about data and data not being clean. I'm sure all of us have seen that. And Pedro, you had an interesting point of view, right? You said that I don't want clean data, I want all the dirty, murky data as well. But what do you do with that? And how do you actually make it useful enough for somebody to consume?
So one of the key ideas of how you solve that problem is thinking about what's going on in the data scientist's mind when they're manually solving this problem. Usually in machine learning and AI, the toughest part is formulating the problem correctly. Once you formulate the problem, if you have a proper target in a data set.
Can you just give us an example?
Sure.
By
So,
formulating it correctly.
great. So there's a paper that came out calling Learning to Learn. What that meant was you have a model, you shove data in, you show the outputs, it learns to predict stock prices, or it learns to predict who's going to switch carriers, right? Learning to learn is you have another model here that watches how this model learns and learns how to tune this model, and that's called learning to learn. And when I saw that, I thought, is that really what the person was doing? And my thought was no, because if that were true, then as a data scientist, every time you went into a project, you would be doing learning to learn. That means you'd be doing the same things. But I noticed that every time I did this learning to learn manually, I was better at it and I was faster at it, which means I was learning to learn to learn. So if you can learn to learn to learn, you can train a machine to learn to learn to learn. And it sounds very complicated, it starts sounding like, is that general AI? No. You can simplify by saying, what is the target? And that's what I mean by formulating the problem. When I'm becoming a better data scientist, what is my brain solving for? That is the problem formulation. And what do I think my brain is processing in order to solve for that target? So what features am I looking at as a data scientist? So the features could be, I'm looking at the performance of the model. I'm looking at the graphs of the data set statistics to just understand the data better. So these are all parts of the problem formulation, is understanding the inputs and the outputs. And a lot of times the outputs are obvious. It's like predicting churn. You have that data. Sometimes that's when it gets complicated, is when the output is not obvious. But that's what I mean by formulating the problem.
Interesting. So Biren, I want to just get to it quickly, right? So we talked about formulating the problem and data problems, etc. Are these some of the same things that you're seeing, or when it comes to enterprises and when it comes to B2B, are there bigger challenges or maybe smaller ones which nobody talks about, which are maybe not so cool to talk about?
For sure. So when we talk about what we do with the data, unlike with data sources that are well known and you know how to parse the data, you know what that data is telling you. When you're getting data from machines that you, as I said earlier, that have got different aspects of data that they're sending back to you, you really need a subject matter expert to understand what data is being sent back. That person is typically not the data scientist. So now you've added yet another level of interaction. The data comes back, the data domain expert is looking at that data, trying to understand what to do with that data and coming up with that problem statement. Then translating that to the data scientist to say, these are the features I want you to look for, these are the signals I want you to look for. And based on what you see, these are the implications that I believe this data is providing to us. And so that interaction of being able to partner up a data expert or a domain expert with the data scientist is where we see a lot of mixed signals and things that get out.
Interesting. I think this has been a debate for a while, and yesterday also we had this discussion as to whether technology is enough or we really need domain. And I know, Ruchi, you had a point of view. And after that, I want to bring in a contrarian point of view with people on the other side who work purely with data and see what they have to say around it. Ruchi, you can go first.
Okay, the thing is that a lot of enterprise, and this is just Ruchi's personal view from her own experience, is AI is such a buzzword. A lot of enterprise specifically are jumping into this bandwagon because they think if they don't throw this word out, they don't stand a chance. So every company you ask, they have hired some AI team, but the business goals, and I think it goes back to Biren's point, is what are the business goals? What are you trying to achieve? And then how it's going to help you grow the business. So for example, even if you're analyzing a lot of data, like what signals you're gonna use and how it fits into your overall business growth strategy, right? Is it gonna be a cross-sell, upsell, making different better products, giving better customer care? What is it that you're gonna utilize this, right? So, and each use case needs to be well defined, well thought of, and then have a strategy around it, right? Like it's a costly proposition. So my thinking is right now everyone is pumping money, but like 2 years down the line, if they can show a direct relationship between the investment they made and the business growth attributed to it, then they're gonna have a real problem.
Right. Jason, I'll get you in. Like you work, your company is called Databricks. So I'm sure you work only with data. So how do you resolve this concern of having domain understanding imperative to solving the problem?
Yeah, I think you do need domain knowledge or domain expertise, regardless of the problem you're solving. And to your point, you have to have like a key metric that you want to move the team along, and then build a model and see if it improves it, and keep iterating on it. Otherwise, you can never fail an initiative because without a clear metric that you're moving towards, it might be a failure. So I worked on a project once in my past where we were trying to predict insurance fraud, but we didn't really nail down the one key metric. It should have been like a few really low level metrics. Then we should try and move the needle on first, and then we could have had like a larger, I think, success.
Could you give an example of it? Something more specific as to like what you missed and how it would have been different if you had the domain things like that?
Yeah, I mean, we wanted to lower insurance fraud. And everybody knows like between 10 and 20 cents over dollar per number is out of the word fraud. Some of it you actually know is fraud, but you still pay it anyway, and others you're not so sure about. But you never, we didn't have like a key metric like claims leakage we were trying to focus on, or even just like a specific type of hit and run flow. So we tried to go too broad without having very specific metrics we could move on. We basically wasted a bunch of time working on that project.
Interesting.
Actually, if I may, I want to add to Jason's point. And I think one of the challenges we face is because there are no set benchmarks right now for AI, right? So like, you don't even know like what is the right metrics to focus on per se.
Right. So I think I just want to pose this to Pedro, right? So Pedro, you worked for 17 years on a dozen of verticals from genomics to fashion. So how important is domain? So you all talk about domain, right? Or maybe is domain something that people who have worked there for 20 years just throw at us to say that it's extremely important? How do you balance this point of view?
I think it's very interesting to see what's happening with the culture around data science in the last 10 years. If people are familiar with Kaggle, it's an online place that it's a competition website. You give your data and you say, here's $100,000. You have tens of thousands of data scientists compete to build a model. And a lot of the Fortune 50 companies put their data on Kaggle. Right? There's this thing I call called Kaggle effect, which is before Kaggle, everybody thought the domain expert with simple statistical tools would beat a data scientist with more advanced machine learning. That's what everybody believed. Kaggle came along, and you had these people that were purist data scientists, understood nothing of the data. As a matter of fact, a lot of the data was anonymized, and they were beating the domain experts by a lot. So then everybody said, screw the domain expert. The purist data scientist is all you need. You never need a domain expert. But that's not really true, because in order to put your data on Kaggle, you need to formulate the problem. You need to put together the features. All of the domain expertise is imbued in the data. By the time the data scientist gets it, the domain expertise is there already. So all that Kaggle proved is that when you have the perfect marriage between domain expertise and advanced machine learning, you get a great result. People failed to see that for, I think, the longest amount of time because they didn't realize that, domain expertise is there. So as a data science purist, I see the massive value in domain expertise.
Nice, interesting. So just another example that we've seen and quite a few of you have heard about this company called Sigma. Again, it's a unicorn based out of India with a clean service proposition of using only analytics and pure play analytics. One of the things that they always claim to do is that we are domain agnostic, we only need your data. They grew very well for a very long time, but for the last 3 to 4 years, they're not doing so well. And they also are looking to take a shift in their own understanding of whether they need to marry data scientists with actual domain experts. And I think that's a realization that people have had insofar. The other thing I want to also look at is, Biren, I'll get you in here, right? Are we trying to overkill with AI? Is AI solving everything? Or are there certain areas where AI is good at and should be, and people should double click on it, and certain areas where, AI is just first?
So I don't know that I would say we're trying to overkill with AI. I frankly think we've just scratched the surface with AI.
Okay.
But there are absolutely certain things that AI does better, and that you should be targeting, pattern recognition and those sorts of things, and being able to do, whether it's supervised learning or unsupervised learning and so on, based on those data sets. Where I think you have to be careful is in more, when you look at a business problem, more often than not, you need a human element to that decision that the AI engine was made for. Too often we just assume that the AI engine will give us the answer, and that is going to be the right answer without adding that human element to it. And so I don't know that I would say AI has reached its limits. Like I said, I think it's just beginning. I think the key is to make sure that you don't forget that last step of using that data.
Interesting.
To Grant's point, we're only just scratching the surface. So if you think about, the Fortune 500, only the top 1% of the Fortune 500 really figured out how to, transform their businesses into an artificial intelligence-driven way. These are the Googles, the Facebooks, the Netflixes. They figured it out, and they're winning. And the rest of the 99% of the Fortune 500 is still trying to catch up. So we are in the early stages, I would say.
Interesting. So, Ruchi, in your role of working with different companies, advising different enterprises, what are the sweet spots that you try and choose first when it comes to showing actual monetizable results in AI and AI and platforms and microservices?
So I think just before we came in, not Facebook. I don't think Facebook is a good example of doing AI in the right way. I think actually that made a really good point, right? So when you look from a business context perspective, if you can focus on one problem at a given time, right? Like one business problem. And I think that's what is missing from most enterprises. They are looking to solve multiple problems at a given time when they try to integrate AI. And I think one good example, if I look at it, is Amazon. When they involve AI, they really solve one problem at a given time. So for example, in the warehouses, right, that they are mostly automated. And the way they are using it in the warehouses is more around how do they arrange and optimize the stuff, so when it comes for order delivery and packaging, they can really do it in an efficient way. So moving forward, I think any business can succeed, but if they really define the problem well, what they're trying to solve for, and then they would be better able to understand how they want to put the business success metrics around it.
Interesting. I think one of the interesting points you made was how companies try to solve a lot of things or try to do a lot more of technology for one particular use case. And Pedro, you had an interesting example of how, in your experience of working with different companies, you've seen them maybe kind of over-engineer to use a simplistic term.
Yeah, I think the whole overkill, in my mind, is not on trying to use AI in too many places. I think it's trying to use AI only in the very moonshotty places, right? Because AI is so expensive and time-consuming that once you put together that team, it took you a year and a half to hire, and half the time, 2 years later, you fire all of them because you have your own people. But beside the point, it's so expensive, it takes so much time, and you're not going to say, oh yeah, build a model to do this tiny little thing that maybe doesn't matter. The thing is, there's 1,000 of these tiny little things, and if you do all 1,000, it would matter a lot. But because it's so costly, they say, well, no, we can't do anything less than a self-driving robot that serves coffee and can fly, and these big moonshot projects. And I think that's the problem. It's once AI becomes easy and cheap, then we're going to really open the spectrum of there's 1,000 projects for every one that we think of, and we're not using AI, and that could improve a business.
Why do you think AI is so expensive?
I think one of the problems is the supply and demand problem of talent. It's the early days of aviation, you had the Wright brothers building the planes and flying the planes. You can't start United Airlines back then because you'd have to train and hire 100,000 Wright brothers. You can't do that. And I think that's where AI is transitioning right now, is advancing the field, reducing the requirements of becoming a pilot, and then you can mass produce pilots and you can have the field of aviation.
Interesting. So, Ruchi, you come from Accenture, right? And services companies are traditionally experts at teaching people, hiring, ensuring that they are upgraded to the level that can be consumed by the industry. So, in your experience, what is that talent problem that is there? Is it really that big? Is it something that cannot be trained for in a few months in a classroom, or what does it actually take?
Because as of now, it's really huge, right? Like finding right talent is huge. Primarily because the technology is so new and it's constantly evolving. Having said that, there are a bunch of startups, who are trying to create a more black box model. So, for example, Pedro's company, right? Like he's saying his grandma can use the product, right? I know a bunch of other startups. They are like earlier. If a data scientist has to hire a specialized team to also do the model hyperparameter tuning. Now there are a bunch of startups who are just doing hyperparameter tuning. There are a bunch of startups who are starting doing the quality of the data sets, right? So they run a lot of statistic modeling to predict how good is your data quality. And I think eventually you will have a platform, right? Like right now, when you build something in cloud, you're not thinking, how do I hire talent to build a cloud infrastructure? You just log in, create an account on AWS or something similar, and you're good to go. So I think we're probably a year or two away from that model. I think it's going to get consolidated, and then you would have this. I think the biggest problem is how do you democratize the data part, right? Especially in enterprise. And that is going to be a hard problem to solve. I again know a bunch of companies who are using a lot of encryption techniques so that data could be shareable across enterprises without violating privacy laws, but they are in nascent stage. So I would say give it 2 years, and then you would have an ecosystem, and then probably you won't need that specialized skill sets.
Interesting. So we have a few more minutes, and I see some interest in curious faces in the audience. So I just want to bring them in. Any questions that the audience has for our panelists? Yes, gentlemen.
Follow up on the answer. Just a second. Maybe give you a mic.
Yeah, I think you asked the question to Ruchi, right? Just like we train people with Java and Python and Node.js and whatnot, why is it that the services company cannot train these people quickly enough to get the talent dirt that we have? Right? Is it not a problem of the people that are coming out with the math degrees, which are really required to create these techniques? Or is it that the data science discipline will evolve to a point that we will not need the actual mathematician doing the actual
Interesting.
analysis?
So I'll point you to two people, right? So Biren, you've been in a large enterprise trying to solve this problem, and then I'll go to Pedro, who's also been teaching AI. So we'll try to get both perspectives.
Yeah, so from my perspective at scale, what I find is, yes, you need the mathematicians to come out and help with the data modeling and so on, but like I said earlier, a big part of our problem is really the data modeling and being able to understand that data, cleanse that data, read that data, and move to the data scientist. So frankly, we have an equal amount of challenge in finding not just the data science skill set, but also someone that understands the data, or enough people that understand the data to use that data available for data science.
So Pedro, you've taught at Yale, right? And is it actually that complex to teach AI and get people up and running?
Well, you say taught. I didn't teach at Yale, but I studied there. I taught in a couple of different other places, the small little courses. But yeah, I think being a mathematician is about 10% of being a data scientist, but that's already 4 years in school. So one problem is that to become really good, you really need to spend a lot of time learning. The second problem is it's a waste of time. It's like having a person that got a degree in engineering that knows how to build jet engines and having them fly a plane. But that's what we're doing. We don't need that. So I'm not saying that that mathematician, the current data scientist, is going to be out of a job, but their job needs to be elevated to something else. If you're studying, you understand the theory behind machine learning that well, your job is to build new jet engines. Other people are going to fly the planes, right? So I think that doesn't exist yet today. The people building the jet engines are having to fly the planes. That's the problem.
Interesting. Any? Please go on.
Maybe it's a question for Ruchi. Is public policy from most of the governments of the world an enabler or a blocker for AI to progress along the lines that Pedro talked about? But by the way, I love those smartphones that have AI enablement on them that make me look younger. Hopefully being late.
So, honestly, I don't know if it's gonna be, it means that data privacy is gonna be a concern, and it's gonna be a bigger concern as we move forward. But I also have a flip view on this. Like, is it really, like, to me, privacy is almost dead, right? Like, we talk a great deal about privacy, but like, these days, if you spend 2 minutes on internet, you can find each and every information about the person. So, I think as long as, like I talked about, there are a lot of startups who are trying to democratize the data where people can share data without revealing actually the critical private information. As long as they are successful, I'm not sure policy can affect, right? I think as long as you don't reveal the key important aspects of the data and get it directionally to make model decisions or train your model directionally, I think we should be good.
So if I were to say, I don't think it'll slow down progress on AI. I think it'll actually take us more time to cleanse the data, like I was talking about. We spend a lot of time, and with regulations like GDPR and so on, there's a lot of work that goes into anonymizing the data, making sure that it can be something you feed into an AI engine. And so that's where I think you end up spending more time.
My question was not as much on the privacy angle, although that's important. It was more around, let's say the applications for public safety and national security concerns, many countries in the world, and non-state actors, right? Has that really heightened the infrastructure availability to enable AI to go faster?
I think we had another question.
This is more for Ruchi. Ruchi, hi. I did completely understand where you came from. All the enterprise customers come to you, consulting companies, and they say that, hey, we have a use case for this AI. And they think that every problem can be solved with AI, right? So, for example, they come to you for a use case, and you get that opportunity to work with the customer, realize that there is no data available. Most of the AI models are built on the data and then the training the data and all this stuff. So when there is no data available, how do you handle such projects, and how do you tell the customer, hey, we cannot do this, we cannot solve this problem because the availability of the data, and how do you handle such situation?
It's not about that data completely is unavailable, right? Like, you can also create some of the data sets, right, for training the models. It's more about the large scaling of the data sets not available. So some of the things, I can bring you an example, like I was talking about, where we wanted to build this product which was embedded AI in the persistent chat, right? To train that model, especially conversations in the business context, right? You could not just take a regular email dump of the consumers and train it. So we went to the CIO of the organization and said, out there, can we get the email data of the, so where people are having that sort of business conversations and use that. So you figured out, where you could get some amount of clean data where you could train your system in a decent way, right? Like, the more you train, the better you get, right? So, based on the business problem, you go figure out where is your best chance of getting the data, and if it's not there, you tell them,
The question is, were you able to turn down some projects saying this is not the right use case for AI because of lack of availability, even though the sets of data that we create, but that's not the outcome that the enterprise.
Yeah, absolutely, you do. and whether they like it or not, but you do, and it's just not on the basis of the data, it's also on other factors too.
Maybe a final question, and then I have one for my. Okay, right there. Okay.
It seems like part of the complexity is the two words that we use, artificial and intelligence. Both are pretty well misunderstood by lots of people. If you call it making better prediction models, it would focus quite a bit. And then I think also if you look at it as a prediction model, it would also help you filter out a lot of the artificial intelligence issues. If y equals mx plus b is sufficient for prediction, then you don't need a complicated model. I guess the question would really be, what do you think about the words being part of the problem of how people apply artificial intelligence?
Okay, slightly existential. So, Pedro, quick shot at that. Is it a concern?
Fantastic point. I think there's a lot of misconception. But I think you could go even simpler. I don't think you even need a model to be AI. I think AI is anything that mimics any form of intelligence, and it's artificial. So a paper towel dispenser in the bathroom, that's AI. If you ask a human being, please pass me a paper towel, they'll give you a paper towel. That's intelligent behavior. If you ask a lobster to do that, the lobster will not give you a paper towel. So when you put your hand in the sensor, you're asking the machine, please give me a paper towel. It responds to the stimulus as if it were intelligent and gives you a paper towel. It's an if statement in the code. If sensors triggered equals dispense paper. Not even a model. So yes, I agree. Models are a subsection of AI. Once that if statement becomes complicated, well, if it's a small hand, it gives less paper towel. If it's very wet, and if it's a child, wait for the parent to come. Nobody wants to write that many if statements. That's when you use modeling, because then you don't have to. But I think AI is a bigger and even simpler, broader definition of just anything that mimics any form of intelligence.
Cool. So I think we've had a very interesting set of questions, and I'll just try and summarize and close. I think one of the key things that at least I learned today is, and something that was reinforced, is how important domain is, and how important it is to have I would say, a happy marriage between domain and the technology experts. I think we've heard it from both sides of the table, so that's a big takeaway. The second thing that we learned is that the talent is partly available and very difficult to train, because what I understood is there's a mix of different skills. So there is mathematics, there is technology, there is modeling, there's all kinds of things involved. So there's no Java language that can be completely learned. As Pedro mentioned, people, even with the largest and the best of skills, are still stuck with doing what we call hands and legs work, and hence not completely utilizing their time. And that implies that for companies like Netapp, it's extremely expensive to work on them, and hence you work on like really expensive projects, and which may or may not succeed. So overall, I think what we've understood is AI is there, AI is important, but it might still take some time before we see AI in complete action. And there's a whole bunch of things that need to be done. Cool. So thank you very much for your time.